Newton's second law of motion. Newton second law of motion. We already studied Newton first law, Newton second law, Newton third law. Here we are discussing unit 5. Unit 5, the topic dynamics. You know, dynamics means it is a branch of engineering mechanics. It deals about study of the body in motion. The dynamics further classified into two: kinematics, kinetics. Kinematics, study of the body in motion without considering forces. Or other definition, to study about relationship between displacement, velocity, acceleration, and time is called kinematics. Kinetics means study of the body in motion with considering all forces. That is called kinetics. Or other definition, to study about relationship between force, mass, and acceleration. Already we discussed kinematics. Now kinetics. When you say the motion, you automatically first consider Newton second law of motion. We know the mathematical equation for Newton's second law. Newton's second law, we all of you know, F equal to ma. F equal to ma. Don't say the F. This is called F net. We can say summation of F. Summation of F. Or F net. Other name, net force. Net force. F net equal to ma. Okay. Equal to ma. What is net force? Just imagine. Suppose the block. This is a block. Okay. It's moving this direction. 100 Newton. Just imagine 100 Newton. We are applying 100 Newton. It's moving this direction, right side. Suppose the rough surface. Just imagine rough surface. Here, rough surface. So friction will be there. So friction always acting, we know, opposite. Just imagine the friction F, friction will equal to 50 Newton. Okay. Consider a block. It's moving right side. The applied force 100 Newton. Here the contact surface, there is friction is there. Friction is acting opposite left side, there is 15 Newton. What is the net force here? Any one of you tell me what is the net force? Net force equal to? Any one of you? 100 minus 50 equal to 50 Newton. This is called a net force. Understand? Okay. Now, I am taking the same block. Just imagine I am taking the same block. Okay. This block is moving. Just imagine the block is moving left side. The block is moving left side. 100. Okay. The friction is in the opposite direction. Just imagine friction force 50 Newton. Therefore, what is the net force? F net equal to any one of you? What is net force? F net equal to any one of you? Louis, Madhuban. What is F net? Madhuban, what is F net value? That is 100 minus 50. 100 minus 50. Generally, what you are doing, the left side force is minus, right side force is plus. That is the actual rule. But what we are calculating? F net. Students, F net. F net means irrespective of minus or plus, irrespective of directions, left side or right side. F net means more maximum force minus minimum force. How do you say maximum force minus minimum force? The body which direction moving, that direction having maximum force. Okay, other forces are minimum force. So now this, imagine this block is now moving left side. The applied force 100, the friction force 50. So block is moving left side. So motion is that left side. Okay, therefore maximum force 100. Okay, I'm taking only positive. That whenever calculate the F net, you have to consider maximum force minus minimum force without directions. See here, this block, same block moving right side, and net force, what is the maximum force? 100 minus minimum force 50. Are the same here applied without directions. Understand? Net force means maximum force minus minimum force. So we are discussing Newton's second law of motion. We know Newton's second law, F net equal to ma. Okay. Then D'Alembert principle. Next important, D'Alembert principle. D'Alembert principle, other name, dynamic equilibrium. Dynamic equilibrium. Dynamic equilibrium. You know, what is equilibrium? The body is at rest under the action of forces. Our body is stable. There is two types of equilibrium. Already I told you. Static equilibrium, dynamic equilibrium. Static equilibrium means, the best example, the chair is always there. We are sitting on the chair. The chair is not moving. Understand? The TV is fixed on the wall. Even though the weight is acting downward, the fixed, no, we are supported. So support to give balances. Static equilibrium. What is dynamic equilibrium? Just imagine the fan is not switched on. It's not rotating. Okay. When we switch it on, the speed is gradually increases, rotation increases. After reaching maximum speed, it rotating constant rotation, constant speed. Now is stable or not? Yes, stable. Dynamically stable. Understand? Dynamically stable. Suppose we are riding bicycle or bike. When you have to stay stable, when you go with constant speed, not frequently changing, accelerated, that zigzag, some trunk and drive people, no, they are going this side, that side, the action will happen, no. That means unstable. Okay, not a dynamic equilibrium. When you have to say dynamic equilibrium, the body moving with constant uniform acceleration or constant speed. Okay, so mathematically, how do you say dynamic equilibrium? F, already we have written Newton's second law, F net equal to ma. So dynamic equilibrium means, just imagine F net minus ma. Students, F net minus ma equal to 0. Dynamic equilibrium. F equal to ma, Newton's second law. Okay. F net minus ma equal to 0, dynamic equilibrium, or D'Alembert principle. Understand? This minus ma, no, this minus ma means reverse effective force. Minus m means reverse effective force. Reverse effective force. Okay. So understand what is the dynamic equilibrium? F net minus ma. So in this problem we are going to solve. Just I have explained what is net force. Then I explained what is the Newton's second law and D'Alembert principle. Just to keep in your mind, we are going to solve these problems. Arun Kumar, can you read this problem? Arun Kumar, can you read this problem now?
two bodies A and B of mass 80 kg and 20 kg are connected by a thread and move also along a long span cornerly plant under the action of a force 400 Newton applied to first body of mass 80 kg as shown in the 24.2.
Okay. So two bodies A and B. Just imagine two body A and B. Mass 80 kg. Mass 80, 20 kg. Are connected by thread. Are connected by thread. And move along a rough horizontal. Student, rough horizontal plane. Whenever say rough means there is really a friction will be there. Students, whenever the rough horizontal plane, rough surface meaning there is a friction available. Okay. Under action of force 400 Newton. The 400 Newton given. That means the block is moving left side. The motion of the two blocks moving left side. Okay. To the first body of M80 kg as shown in figure. The coefficient of friction between sliding surfaces. Sliding surfaces, plural, surfaces. So two block, no, A and B. So two surfaces, plural. So whenever friction will be there is you have to think about mu. The mu will be given, coefficient of friction, mu. The coefficient of friction between sliding surfaces, the bodies and the plane is 0.3. Therefore, mu equal to 0.3. Here mu equal to 0.3. Understand? Now what they asked, determine the acceleration of the two bodies and the tension in the thread. Determine the action of the two bodies and the tension in the thread. No, rope, no, thread means rope. Okay, definitely tension will be there, no? Okay, using D'Alembert principle. Using D'Alembert principle. Student, just imagine this two block, A block and B block. A block given 80 kg mass, B block 20 kg mass. The force is applied in the left side. Therefore, the block is moving left side. What they asked, determine acceleration and tension. See, the engine is front side. Just to see the railway engine. The engine is front side. Then the connected with the series along the other compartments. If the engine goes to some speed, the other compartment also goes with the same speed. Understand? Similarly, here the acceleration of block A and the acceleration of block B same. A is constant acceleration. Understand? A is constant. That is acceleration of block A equal to acceleration of block B. Like rail engine. Okay. So we are using D'Alembert principle. What is the D'Alembert principle? Just imagine. F net, I told you, F net minus MA equal to 0. Okay. So I'm taking block A. I'm taking block A. Block A. Okay. So block A move which direction? Left direction. Understand? With the 400. Then here the tension I told is connected which direction? This direction. When you consider these two block, T is connected, 30 is connected, no. So consider this direction, the tension is this direction, left side, because connected. And is moving, which direction block is moving? Left side. What would friction, students? Friction which direction? Opposite direction. Friction is opposite direction. Friction is opposite direction. Okay. We know weight is acting vertical downward. Weight is acting vertical downward. Okay. And the normal reaction. Students, normal reaction upward. Normal reaction upward. Normal reaction upward. Okay. Normal reaction upward. Here, weight. Weight equal to what? We know mass into gravity. Mass into gravity. What is the mass? First block, 80 kg. Understand? 80 into 9.81. Okay. Here tension T. Students tension T. Here force 400 Newton. 400 Newton. Here normal reaction. We know R. Understand? R. Here F. Why friction right side? Because body moving left side. So friction equal to, we know, already we studied. What is F? F equal to mu into R. Can you remember? F equal to mu into R. Now, we are applying which law? D'Alembert principle, F net to minus MA. What is I told you? What is F net? Anyone tell me from the diagram? What is F net value? Any one of you? Students, see the diagram. What is F net value? I told you, what is F net? Maximum force minus minimum force. Irrespective of direction. Which direction the body moving, that is that direction positive value. The other side negative value. Any one of you tell me what is F net value? Any one of you? Any one of you? Louis Paul? Louis, what is F net? Louis, Madhuban? Arun Kumar? What is a net force? Net force means I told you maximum force minus minimum force, irrespective of direction. So this block moving which direction? The given question, the 400 Newton here applied here, left side. So the block is moving left side. So which is the maximum? 400 is the maximum. Students, 400 minus mu r, okay, minus T. Understand? This is F net. See here, F net value. F net 400 minus T minus F1. Block 1, no? We know F1 equal to what? mu1 into R1. Students, mu1 into R1. What is the mu value? 0.3 given. What is R value? See the diagram. What is R equal to what? W, no? The upward force, downward force, the vertical direction. What is the W? 8 into 9.81. Therefore, they calculated R equal to 8 into R equal to W1, no? R equal to, that is vertical force. We know summation Fy equal to 0. Summation of Fy equal to 0. Vertical direction, students. Vertical direction. Therefore, R1 goes to upward minus W equal to 0. Therefore, R equal to, what is the W value? Mass into gravity. So R calculated. So we know mu 0.3. Therefore, see here. R equal to 80 into 9.81, 784. They applied here. After applied here, the final equation F net equal to this value. F net equal to, not P1, F net. F net equal to 164.8 minus T. How they got? Maximum force, other side minus force. Minus T minus F. What is F? Mu into R. What is R value? That is weight. So they got, we applying what equation? D'Alembert principle. What is the D'Alembert principle? F net minus MA. See here. F net MA equal to 0. We calculate F net, this one, 164.8 minus T. Minus MA, no. What is M? 80 kg. 80 kg. Okay. 80 kg and acceleration. So they found first equation. Acceleration, we do not know acceleration. We want acceleration. So they formed first equation. Understand? That's the same method for applying second block. Apply the second block. Second block, just imagine. Second block. Okay. The block is having how many weight? 20 kg. 20 kg acting downward. See, kg given, I told you whenever kg given, you convert weight. That is a W equal to, students, 20 into 9.81. Why I multiply 9.8? 20 kg, 20 kg, therefore I multiply weight. Okay. Then every action equal to opposite reaction. R. So they connected with tension. How, which direction tension? This direction tension. So tension, no, here only connected, tension only. Friction. The block is moving which direction? B is moving motion left side. Friction is right side. Students, F equal to mu into R. We are applying D'Alembert principle. What is the D'Alembert principle? F net minus MA equal to 0. Minus MA equal to 0. What is F net? I told you, no. So the block is moving which direction? Left side. So left side may force a maximum force. So for T is the maximum. T minus, that is minus mu into R. That's only, that is F net. F net equal to F net T minus mu R. Understand? Okay. Minus MA. See, F net we calculate. Students, this is F net. Okay. Then MA minus MA equal to 0. Equal to 0. See, in the single equation applied net force and already D'Alembert principle, no, minus MA. So equal to 0. Therefore, T minus, what is the mu value? Mu value given already 0.3, coefficient of friction 0.3. What is R? R equal to weight, no. So 20 into 9.81. Students, 20 into 9.81. Minus M. Minus, what is the M value? 20 kg. 20. Acceleration equal to 0. Understand? We drawn the free body diagram. See, in the block A, B, only 20 kg. See here, 20 kg. So weight is acting downward, 20 into 9.81. So connect the thread, no. So thread means tension. So tension left side. So friction opposite. Because the both block moving left side. Then every action equal to opposite reaction. We are using D'Alembert principle. Students, D'Alembert principle. What is D'Alembert principle say? That is F net minus MA equal to 0. I told you what is F net? Irrespective of direction, maximum force minus minimum force. Which direction the body is moving? Here the body is moving left side. So left side force is maximum force. So maximum force, what is a T? Minus minimum force, the friction force. Okay, I calculated F. This is F net, understand? F net. This is the equation minus MA. So finally, we find the equation 2. See here. Equation 2. See here. Equation 2. So we have equation 1, equation 2. After simplifying the acceleration, we got the acceleration equal to 1.06. When apply acceleration again, the equation, any one equation, here we got tension. Understand? Students, any question? Any question? Uday Kumar, class rep, any question? Arun Kumar, Louis, Naresh,
No questions, sir.
Nitin, Nitish, Shiraj. Okay. So just remember, I am repeating this equation. We are using new D'Alembert principle. What is the D'Alembert principle? F net minus MA equal to 0. What is the Newton's second law? F net equal to MA. Okay. What is F net? Irrespective of direction. Maximum force minus minimum force. Suppose the block is moving left side. The left side means take as a positive because that side is the maximum force. The other right side minus. Or suppose the block is moving right side. Right side take as a positive. The left side forces are minimum force. Understand? We friction involved. No, already we same discuss the topic discuss the friction also. Here we introducing the MA. Additionally, we introduce MA students. MA. Okay. So now I am sharing one YouTube lesson that it's a Newton second law. They use Newton second law. Just imagine what is the difference between Newton second law and D'Alembert? F net equal to MA, Newton second law. F net minus MA equal to 0, D'Alembert principle. Okay, you can understand the problem. Any doubt you can ask me after the end of that video. Okay, now I am sharing.
inside. Now guys, whenever you are solving problems with laws of motion, always try to work out forces that are dominating the motion. So you can clearly see motion is towards the right hand side, and the force towards the right hand side is this one, this T. That means this T is dominating, okay, with respect to this friction force. So what we can do is Q has to be taken as positive, P, this is towards the left, minus friction force whose magnitude is 2.5 G, and that's it. That's all the forces that we've got will be equal to the mass. How much is the mass? M1, where is M1? It's 10 kgs times of acceleration, that's T. Okay, let us say that this is equation number 1. Done and dusted. Block 1 analysis is over. Now let's carry out the same analysis for block 2. Okay, so it's going to be something like this. Very simple. If you write this quickly, block M2. Okay. Now you can clearly see that the motion is happening along the vertical axis. Now check which force is dominating, and for that I need to apply the force over here. So obviously this string, and there is going to be some weight. Figure out this right now. Weight of this block. So weight is mg. Mg, how much is it? M is 5. So I can write 5g over here, where g represents the acceleration due to gravity. And due to this weight, there is going to be tension. Okay? Okay, which is going to have a magnitude of T. Alright. Between these two forces, can you tell me which force is dominating? Now, since the motion is happening in the downward direction, that means you can claim that this force, Ig force, is dominating. Therefore, this will be taken as positive, and the force opposite to this one, that is this tension T, will be taken as negative. That's the sign convention that we're going to be following right now. And here we go. Summation of all the forces in y direction is equal to mass into acceleration. So the block for which analysis is being done right now is block 2. It's going to be M2A, and the acceleration with which it is going downwards is represented by A. That's why we've written A over here. Alright. So the force dominating is this one, 5G. Okay, right now we're taking the direction of dominating force as positive. Okay, so this will be taken as positive, and this over here will be taken as negative. That's why this is 5G positive. T will be taken as negative. So if we write this, 5G minus T is equal to mass into acceleration, block 2 mass, 5 kg, 5 times of weight, and that's it. That's equation number 2. Now you can clearly see that we have to calculate two outputs in the form of tension and acceleration. We have two equations. Okay, this is unknown T, and this also is unknown to us. Acceleration T and A. We have two equations. We have two unknowns. G is already known to us. How much is it? 9.81. The best thing to do right now, you can clearly see this T is positive over here. This T is negative. So what I'll do is I'll add these two equations, equation 1 plus equation 2, and let's see what happens. So T minus 2.5G, let me write this in totality, 2T minus 2.5G, okay, then plus 5G minus T is equivalent to how much? This is 10A and this is 5A. So 10 plus 5A. So guys, you can clearly see these two things will cancel out. 5G minus 2.5G is obviously 2.5G only, which is going to be equal to 10 plus 5 is 15, 15A. So acceleration will work out as 2.5G 15, 2.5G, and the value of G is how much? It's 9.81 over what? It's going to be 15. So the value of acceleration works out as, let me have this. Okay. I'm sure you guys must have noted that friction thing. I need some space over here. So the value of acceleration is going to work out as, let me check how much it is. You can do this calculation in a calculator. And this eventually works out as 1.635 meters per second square. 1.635 meters per second. So that's the value of acceleration obtained. Now you can put this value of acceleration in either equation 2 or in equation 1 to get the value of tension T. It's going to be very simple. Now let's frame this equation to in a better way. So I can this as 5g minus t. Let's take t over to the right hand side and 5a will come over here. So t is equal to 5g minus 5a. T equals 5g minus 5a. So you just need to put the value of g and eventually you're going to get the value of tension T. So tension T will give you 5 times of 9.81 minus 5 times of acceleration 1.65. 1.65. So you just do this calculation and the value of T shall work out as, let me tell you, 40.875. 40.875 newtons. So that's it. That's the tension T in the string, and that's the acceleration with which this entire system is going to move. Okay. Block M2 will go down with an acceleration of 1.60 and block M1 will move right inside with an acceleration of 1.
Students, in this problem, two blocks of masses M1 and M2 are connected by flexible but inextensible string as shown in figure. Assuming the coefficient of friction between block M1 and the horizontal surface to be mu, find the acceleration of the masses and the tension in the string. Assume M1 mass 1 10 kilogram and M2 5 kilogram, mu equal to 0.25. Understand? Say here one block is resting on the horizontal surface. Another block is hanging through roller. Student, through roller is hanging. The M1 5 kg, M2 5 kg, M1 10 kg. So automatically, generally, see here, this is vertical hanging. Even though small mass, but it can pull down, no? So both the block having same acceleration. Student, same acceleration. Under the single rope, single inextensible rope. So tension also same. Okay. Here he is applying Newton's second law. What is Newton's second law? F net equal to MA. See here, MA is here. MA. What is F net? See the horizontal block. First block. So tension right side, friction left side. Weight is acting vertical downward. Normal reaction upward. Okay. Therefore, what is the weight? 10 into 9.81. That's why he put in 10 into G. G equal to 9.8. No, 10 into G, vertical downward. What is the net force? P minus F, friction. What is the friction? F equal to mu1. What is the mu? 0.25. What is the N value? 10 G. Therefore, 0.25 10 G, 2.5 kg. G equal to 9.81. He did not multiply. Okay, equal to MA. What is the M? 10. Mass of the first block into acceleration. So equation 1. Understand? Net force means maximum force minus minimum force. See, come to this block. This block is hanging. See, hanging, there is no friction. Students, no friction. Only contact surface friction here. See, the block is moving which direction? Downward direction. So I told you, what is net force? Which direction moving? That direction is the positive. Other direction negative. So the 5 kg moving downward. Therefore, 5g minus t. See here. 5g minus t equal to mass and acceleration. That is the Newton's second law. What is M5? So two equation. Okay. Therefore, after replacing, we can cancelling everything. We got A equal to 1.655 meter per second squared. Okay. And mu equal to 0.25 given. Tension apply here. T equal to 0.175 Newton.